Hello, and welcome to Backer Breaks It Down. Today, we're going to look at input and output. Now, we previously saw these two concepts in Chapter 1, but we are revisiting it once again in Chapter 2, as we're going to be doing a little bit more with input and output in this chapter than we did in the last chapter, okay? So basically, this is serving as a review. We're going to talk about evaluating a function and solving a function equation. Okay. So remember that a function is a relationship between two quantities, an input and an output, that assigns a single output value to each input value. That being said, when we evaluate a function, we calculate the value of the function's output given a value of the function's input. So following the definition of function, we should only get at most one answer when we evaluate a function, okay? When we solve a function equation, well, we do just that. We calculate the value of a function's input given its output. So examples 1 through 3, we are evaluating a function, and that function is f of x equals x squared plus 3. So problem number 1, like seriously, you saw problems just like that in chapter 1, right? The -2 is inside the parentheses, so we put it into the function for x, and then we calculate the results. So -2 squared, we know that to be 4, plus 3, we get 7. Number 2 looks a little bit different than what you saw in chapter 1, mainly because of that f of a. But what does it mean when we evaluate a function? It means we know the input, so let's put it into the function. So f of a, we would get a squared plus 3. When it comes to that minus f of 2, well, we need to evaluate the function at 2. So I'm going to do a little bit of side work over here. So if I go 2 squared, I get 4. 4 plus 3 is 7. So I have f of a minus f of 2. F of 2 is 7. Combine like terms, I get a squared minus 4 as my final answer. Okay, so we didn't see anything like this in the last chapter. In the last chapter, we were always substituting in actual values and not variables. Or in the case of number 3, variable quantities. All right, but just keep in mind the idea when we evaluate a function. We replace x with whatever's inside the parentheses. So what that means for number 3 is I'm going to take that x out. I'm going to replace it with a minus 2. Okay. And then everything else about the function stays the same because it was x squared plus 3. So that's the first step, is make that substitution. We took the x out and we put a minus 2 in its place. So make the substitution. Once you have that written down in front of you, simplify it. In order to simplify a minus 2 quantity squared, I need to FOIL. So check that out. I did that here. So this is what we were just looking at on the previous page. Okay, a minus 2 quantity squared, what does that mean? It means I need to multiply a minus 2 times a minus 2. Okay, in order to multiply something like that, we're going to FOIL, which you may recall from either Algebra 1 or Algebra 2. The F in FOIL stands for first, so you multiply the first terms together. That's how I got a squared. The O is for outside, so a times -2. That's how I got -2a. The I is for your inside terms, okay? And then the L is for your last, so -2 times -2 is -4. All right, that's how we properly square a binomial. Then it's just a matter of combining like terms. So -2a and -2a is where I got the -4a, and clearly positive 4 plus 3 is where I got positive 7. So a squared minus 4a plus 7, that's my answer here, okay? So it evaluates a little bit different than what we saw in chapter 1. okay? Because they might have us evaluate at a variable or at a quantity, okay? Let's take a look at a few more examples. So in problems 4 and 5, we are given a function and they want us to find f of 0 and they want us to solve the function equation f of x equals 6. So f of 0, that's easy. I'm simply going to replace my variable with 0. So what does that look like here? It means I will have 3 divided by 2 minus 0. And then if I do my math, I simply get 3/2. Okay, and that's my answer. For f of x equals 6, at first glance, it's like, what's the equation that I'm solving? Well, remember, we need to rewrite it. F of x is the function 3 divided by 2 minus x. So it's this is equal to 6. Okay, so this is a really simple rational equation. We can solve this by cross multiplying. So that's like what I'm going to do. I'm going to go 2 minus x times 6. I'm going to write it like this, and then I'll worry about distributing in my next step. And that's going to be equal to 3. Okay. And then from here, I'm just doing some basic algebra to do my solving. So 6 times 2 is 12, minus 6 times x is 6x. This is equal to 3. And then you basically got the rest, because it's just a matter of algebra from here. So if I simplify negative 9 over negative 6, I get positive 3 over 2. It's just a coincidence that that's what I got for f of 0. Okay. So we didn't see any rational equations in the last chapter. I think we were solving like linear type equations. So yeah, that's kind of something different to this chapter as well. So let's take a look at another problem. We have the function f of x is equal to the square root of 10 plus 2x. We want to evaluate at f of 0 and solve f of x equals 6. So evaluate, that's easy. Simply plug in 0 for x. So I would get 10 plus 2 times 0. And that is simply going to be equal to the square root of 10. And that's just a decimal, so I'm going to leave it like that. I feel it's perfectly fine just like that. For the second part, we are solving a function equation. So the first thing we want to do is we want to rewrite it. So replace f of x with the actual rule. So we get 10 plus 2x equals 6. Now it's the square root of 10 plus 2x. So in order to solve this, I need to undo that square root. You know how you do that? Yeah, you square it. So I'm going to square both sides. So squaring both sides will undo the square root of 10 plus 2x, giving me simply 10 plus 2x. And this is equal to 36. And then from here, we're just doing some basic linear equation solving. So 2x would be equal to 26, and x would be 13. Okay. So when we solve function equations in this chapter, they're not all going to be linear equations. You could have a simple rational equation or a simple radical equation like this one. I think you might even see some simple quadratics. Exciting. All right, so one last thing to talk about is doing these two things, evaluating a function and solving a function equation given tables and graphs. Okay, so problems 6, 10, and 11, all of those are evaluate problems. So remember, when we evaluate a function, we know the input. The question is, what's the output? So in number 6, it says a of 4. All right, well, looking at these functions, our graph is a of m, and our tables, we've got p of t and d of t. So for a of 4, I want to look at the graph. And what I want to do is I want to find the point on my graph that has an x value of 4. Here it is. So my solution here will be the y value. Notice that my y value equals -3. So that would be the solution to number 6. A of 4 is -3, because that's the point on that graph. Okay? Nice and simple. So 10 and 11. In number 10, we've got D of 20. So D of T is the bottom table. Remember, 20 is an input. So if I find an input of 20, the corresponding output value is my answer. So D of 20 is equal to 49. And lastly, P of 5. So the function P is the table on top. 5 is an input, so I find that value. Here it is. And the answer is the corresponding output value. So P of 5 is 0. Solving a function equation, giving a table and a graph. Okay, so when we solve a function equation, it means that we are going to calculate or identify the value of the function's input given its output. So let's start with number 7. 7 says P of t equals 14. All right, so P of t, which function is it? It's not the graph. Here it is. It's the table. Okay, so remember 14 is the output because we are given the function's output. So we're going to find 14 in the output. And so my answer is the corresponding input value. So -1. So I would write t equals -1. Number 8, we have d of t is 72. D of t is the function represented by that second table. 72 is an output, so I find it. Here it is. The corresponding input is 40. So number 8, t is equal to 40. And then lastly, in number 9, we have a of m equals 0. A of m is the graph. So whenever I'm solving an equation using a graph, I like to draw a horizontal line through y equals 0. So this green line is the horizontal line representing y equals 0. How many times does it cross or intersect our function graph? You are correct. There are 2 places where it crosses or intersects the function graph. It happens right here when x is 3, and it happens right here when x is 9. So number 9 has 2 solutions. One of them is, m equals 3, and the other one is 9. So that's your recap of input and output, focusing on evaluating a function and solving a function equation. When we evaluate a function, we know the input and we are calculating the output. When we solve a function equation, well, we know what the output is. We're actually solving the equation to find the value of the function input. And that's how Backer breaks it down.